Okay, ladies and gentlemen, thank you for joining this most recent IEEE Hangout on Google+. My name is Stuart Williams. I'm the Vice President of Research for Technology Business Research. Today we're going to be talking about the subject of big data, and I'm joined by two experts in the field. First is Mike Ames, who's the Director of Data Science and Emerging Technologies at SAS. And our other expert is Greg Arnold, who's the Senior Director of Engineering with LinkedIn. Certainly these are two firms that anybody who's been messing around with social networks or big data, doing analytics for a long time, are aware of. So we're going to have an energetic conversation today. We're going to begin by talking about some of the definitions of the changing concepts of big data as we reach the inflection point and we start getting new types of data from all over the world with devices. We're going to talk about skills and skill gaps, how firms are going to be able to address this, the evolution of algorithms versus heuristics, and we'll talk about the value of data, among other topics. So let's just open up the conversation today. First one is an open question. We've talked a lot about big data over the years. The definition goes back over 10 years now. So we have rising volumes of data, increasing amounts of data coming in at higher velocities, different data types. What's the future of big data as we go forward? I mean, it seems like there's a lot of FUD, fear, uncertainty, and doubt that's been attached to the term big data. Maybe it's getting a little bit wear-worn. Gentlemen, what do you think about this as we go forward? What should engineers and computer scientists be thinking about in terms of big data?
Well, I guess I'll go first. So I don't see data declining in any way in the future. In fact, at LinkedIn, we're thirsty for gathering more and more data so that we can generate insights for our members. In the old days of LinkedIn, 10 years ago, when everything was powered off of a central database, it was easy to do both transactional queries as well as analysis on aggregates of information with fairly simplistic tools. But as data expanded, then we had to actually separate into distributed transactional stores versus then piping the data into alternate systems for aggregate analysis. You know, LinkedIn, our mission or our vision is to create economic opportunity for every professional in the world. And one of the things that we've been able to do by having everybody put their profile information on LinkedIn is create what we will internally term an economic graph. And that is a representation of who's on LinkedIn, who's going where, what companies are losing people, what companies are gaining people, who's posting what types of jobs, what are the educational institutions, what are they graduating, what types of folks. So we're able to then draw in all of this data and generate insights, and it's only going to continue. Michael?
All right. So I'll echo that. I mean, at SAS, you know, we look at if you ask our CEO what big data is, he just says it's just data. But it really is the volume of data and that velocity of data. I know those 3 V's get overused, but really it's the exceeding your ability to compute things with it. And so, you know, our mission is to push advanced analytics as far as we can on huge volumes of data, but also do advanced analytics on streams as well. So capturing things at point of transaction and the like is a big initiative for us here. So it's not just the size, but it's also the speed and latency of ingestion that you have to look at as well.
Okay, so I think the opening salvos have been said. We've got the ice broken here on our conversation. Just want to remind those folks who are watching the Hangout today that if they have questions, they should go to Twitter and use the hashtag RSB is in boy, DA, big data analytics, and send those questions in. We will moderate them and pass them back to our panelists today. So one of my follow-up questions, certainly when in our research, when we talk to organizations, either small, large, or very large enterprises, when they're wrestling with data, it's all part of their business process. So the people who are responsible, and then there's IT issues, and then there's business issues. The people in the business really probably don't have a very clear understanding of the amount of and volume of data and what it means to the IT operations in order to answer the questions that they've got. So before we get into some of the other questions, I really want to begin to understand how do we help businesses that, not net new businesses that are looking at new types of economics as LinkedIn is, but your banks, your manufacturing companies, they face this huge hurdle both in IT and in the business to begin to address the volumes of data that are coming in, and then a whole host of secondary and tertiary issues that roll out after that. So I'd like both of you to both talk about, what are the things that are really contingent for people to get their hands around big data and to begin making value out of it.
Let me take that. I'll start. For us, I've had a lot of dealings with companies that are moving to Hadoop, especially the big banks. There's been a lot of energy and effort around the Hadoop ecosystem, and that seems to be now becoming more of the domain of IT, whereas in the past it might have been a research project. And with that, they're expecting things like security and governance and the features and functions around resource management that, quite frankly, the Hadoop community is just late to the game on, or they were more worried about handling the volume of data and not as much with securing data at rest, and what does that really mean in an IT organization? And that's been a challenge. I think for the business side is being able to communicate to the IT organization, hey, we have needs for huge volumes of data. Your chargeback, internal chargeback schemes of charging me by gigabyte are no longer going to fly because we now want to analyze terabytes of data. And I may only want to look at pieces of data for 2 or 3 weeks or 2 or 3 days, and then I want you to pitch it. I need these large sandboxes of storage carved out specifically for certain projects that may or may not come of value, where you can't carve out like a reporting project where you could hand it off to IT and they could go and throw some consultants at it. It's no longer that kind of business model when you get into these big data systems that are out there.
Greg, do you have a point of view on that?
Yeah, I'd like to build on that a bit. You're absolutely right, Michael, that it seems like we, with Hadoop, you've got massive power, but we've kind of stepped back in time 10 years from a maturity standpoint. We expect our we expect our data folks to be able to do Java MapReduce, Pig, and Hive scripts, and it's no longer just simple SQL queries here into a Teradata repository. I think that your question, Stuart, was if I were a manufacturer, my core data competence is not, or my core competence is not navigating through data, then how do I deal with and take advantage of big data? That's a really tough question for, given that LinkedIn is all about data. We've got all the talent here, and so I'm trying to put myself in the shoes of somebody who is a manufacturer whose core competence is not data, and it really kind of the starting point, frankly, is to look at what the commercial tools are out there. There are companies that are evolving that really help you to adopt and embrace and leverage Hadoop. And leverage the transition of Hadoop from Hadoop 1.0, which is very specific to MapReduce, to Hadoop 2.0, which allows you to run alternate computing frameworks. Well, if you're a manufacturer and your competence isn't big data, you won't really understand what the difference is between Hive on Tez and Tajo and Impala. But there's a lot of companies out there that can help you navigate those waters as well. And I guess that's where I'd start.
Yep, and I know that in our research, we ask people around the maturity levels that they have in consuming different types of analytics and the ability to process and integrate data with analytics. And traditional reporting dashboards, people are good with that, right? They know how to do that. The big barrier that they face, which is like a cliff face to them, is this idea of integrating the volumes of data from all these different sources that are coming out. I mean, the tropes we talk about, these V's, are really, really true, particularly in a live environment, because we brought up, say, like an automobile manufacturer. When you think of the amount of data that's either currently coming or going to be coming from their fleets of cars, coming back to the manufacturing through their supply chain, some of that data won't be good data, or they'll change from model year to model year. They'll change types or descriptors, and they'll change their personnel, they'll change their supply chain. That data has to flow through that entire supply chain in order to get down to, say, a parts manufacturer who's tier 3, to really, have them improve the quality of a piece that results in the change of the quality of the car. It's not just a single vendor problem. There's a whole ecosystem of people who consume this data going back up the supply chain, and some of it isn't immediately relevant to the vendor, to that say that car manufacturer, but it may be incredibly valuable back up the supply chain. So thinking through the implications of this is, I think, going to be as much a revelation as the thinking that went into devising the lean, manufacturing supply chain, coming from the tiers down to the owner. Now there's an information supply chain that's going to flow back the other way. Manufacturing, I think, those folks are pretty competent and very clear on those types of processes, so at least they have that mindset and some of those tools in mind, if it's a metaphor that works for them. Other companies need to step up and bring new views and say, hey, maybe there's a community of data here. Maybe there's a way to share it that is different than the piping of a supply chain. What do you guys think about that in terms of like the ecosystem of big data, and particularly where things are so transient over time? The values change from when one data type is defined to the next.
No, I think you're absolutely right. No longer is it just the data that's available to you that you generate yourself. Now you need to actually create an ecosystem and import data from third parties as well in order to derive value. So, for example, there's the data that you put in about yourself in LinkedIn. There's your connections, your recommendations, your contacts. But in order for me to make it easy for you to stub out your LinkedIn profile, we integrate with other third parties, like Google, for example, where you can import your contacts into LinkedIn. And then, frankly, you can have an ongoing importation in real time as to between what you're doing on Google with Gmail and LinkedIn as well. We have tens or hundreds of sources that we are integrating data into from LinkedIn. There is no one standard out there. So with every engagement, we have to manually go over what's the schema of the data, if it's thankfully structured, and then set up custom parsers and validators of that data as we import it on a routine basis. Being able to detect breakages in that data as you're importing it, sometimes every 5 minutes you're kicking off the import function. Is key to the success of the integration as well. But there are no standards out there right now that I know of, apart from just making sure that we agree on schemas.
Mike, you have any feedback on this point of view?
I would say I'd go back a little bit and mention something that Greg mentioned, which is, the big thing I see is the transition of traditional businesses to, while their core competency may be manufacturing or something else, to really having to build the core competency around data management, and then taking more of a systems approach to the life cycle of data, if you will, of from the point of ingestion, integration from multiple sources, the cleansing. All the problems just scale up as you add more volumes of data to the system, and then the variety. Mixing and matching semi-structured data with Word documents and potentially structured data. That becomes a big search problem. But in order to do something of value, a lot of times you end up having to restructure the data into a nice tabular rectangular form that you can analyze it with. And that still is, it's a problem that's been persisting since the time that computers were invented, I guess.
Yeah, the classic problem of what humans perceive as information and what computers perceive as data is a big gap. So when I think about the issues of people wrestling with just the data side of it, Mike, you mentioned that data integration flows, data management, storage management. These are kind of the technical sides of this. And I think there are big opportunities in the ecosystem. We see them in our research for new tools, because certainly businesses aren't going to add more people just to manage the data flows. They need scalable tools.
Yeah, I mean, what I see is self-service is a big initiative in the software industry, right? I want to put tools in the hands of a business user that they can be successful with without constantly having to go back to IT with. And on the IT side, really, they just want to provide a provisioning environment. You have sufficient computing and storage capacity to do your work, and here's the tool that we suggest you use because we've instrumented it and it's been vetted in our environment. That's one of the big things that we see. And the Hadoop community, that's pretty common there, right? They'll grab just about any open source project, give it a go, make some determinations about it, pitch it, take a look at commercial software, see what's out there. But I think that's really where I think things will head, is providing that self-service. I want to have some tools to structure and integrate some data. Then I want some pretty simple tools to analyze it. And by simple, not necessarily be simple to use, very powerful behind the scenes, right? I don't need to have a PhD in statistics to build a data mining model. I simply need to, pick some things that I want to predict and have the machine go figure out what the best models to fit the data might be. Those are the types of things that we're really seeing a lot of demand for.
I think
go ahead, Greg.
No, that's a really good point, Michael. I think that as you look at the volume of data that we have, self-service is more than just, hey, here's a tool that you can use to run a report or query the system. And self-service has to kind of go along the entire stack. So we've got 1,000 different users of Hadoop in LinkedIn. And so we need to give them tools, not just to be able to run reports, but to be able to tune their Hadoop jobs. For example, we wrote our own tool called Dr. Elephant, go figure, for Hadoop, and it just looks through all the jobs and looks through opportunities to tune them, and just recommends, hey, this is how you should probably redo your mappers and reducers, for example, on 1.0. It's got to go from there to self-service tools for data ingestion. If you look across all of the different data ingests that we do at LinkedIn, we see a pattern. We see a pattern for the normal set of workflows of what you have to do. You have to set up different parsers, different validators, extractors, etc. And we've been able to create a tool called Goblin, internally named, to gobble up the data and import it in to Hadoop in more of a standardized manner or a plugin type manner. But that's now that is a self-service tool that is used beyond just a central team. So you're right that the self-service tools needs to extend beyond the entire stack, beyond just reporting and visualization.
Yeah. So we're talking about an era in the next. If data is going to continue to explode, the opportunity for the technology to enable self-service, to enable to be, I would say, flexible with data models that might be broken or streams that might be broken, repositioning data into tabular form, the way that Mike mentioned. Big opportunities there in the marketplace. I want to pivot this a little bit and then talk a little bit about the business side of big data. So here we have many, many different issues. So let's start with the one that's always on the top of every business and IT leader's mind, which is security, right? So Hadoop, we have Hadoop Ops. A lot of ecosystem trust that by default. Is it, in your opinion, is it really safe? And what are the things that, as we go forward around data security, that are going to be either integrated into platforms or that people need to make sure they have addressed as they build out their big data analytics?
Okay, I can start with that. So that's a good point around how do you secure your data in general. A lot of focus on securing your data is placed on the data that's in the repository in Hadoop. But what about the data as it comes into Hadoop? What about the data as it's queried? Frankly, the most severe attack you're ever going to get, the most severe breach that you're ever going to get, is not going to come from outside your company. The biggest threat or the biggest vulnerability you have, frankly, is inside your own firewall. We establish different trust zones. Our developers actually do not have access to our Hadoop repository. If they want to debug something, they have to have the Hadoop Ops guys pull the logs for them. And it's such a pain, but that's the care that you need to take. Now, what about your Hadoop Ops folks, right? What's to prevent somebody from going rogue in Hadoop Ops as well? There we have different trust zones in our Hadoop operations, and we rely a lot on the logs, which frankly record every interaction that we have with our queries. Even that, frankly, doesn't solve all the vulnerabilities. So I'd say it's a fantastic question, and it goes beyond just the data store.
Greg, I don't want to react too powerfully, but there's no promises that you can make, right? So when we've run our research, we ask people about different areas of security. Sometimes we'll say, what are the key areas? And we'll list 5 options, and then in a A/B test, we'll add 10, and then another we'll add 15. People just keep checking the boxes, right? You can never have too much security around areas. It is a huge issue. Need to attack it in a multi-step, multi-phase, and multi-pronged directions, right? You can't. There's no silver bullets here. It's as much about procedure and people as it is about encryption and hardware and safe application code. It's data hygiene across the landscape. Really, this is a huge issue, and we see opportunities for this. Interestingly, in the news in the last week, we saw Symantec, looking at some breakups in its business landscape, and part of the value of Symantec was always in the endpoint protection. But now, the era we're in now, so much is about data that's in process, it's in flow, business processes that need security. It's not the endpoint. So, here's my question: if there is a broken paradigm in their heads about big data and security, people thought that the endpoint was the point you needed to secure, but it really was other areas. What what are those other areas?
So I think what you're asking is beyond Hadoop, we're focusing, I think, a little bit too much on securing the data in Hadoop. Frankly, if that data was in Teradata, if that data was in Oracle, I mean, somebody is going to have access to data, right? And so how do you secure it regardless of where it's at? How do you make sure that the people who do have access to it do not have the facilities to alter it in any meaning or in any undetectable way? Frankly, that's what SOX compliance is all about, right? And the IT general controls is to make sure that you have audit systems here to be able to then validate that the data hasn't been altered or maligned, either programmatically or manually. We are SOX compliant, we are PCI compliant, we've gone through all of these procedures here, but even so, even when you do all of that, there's always an exposure that one has that you haven't really kind of thought through in advance.
And Mike, what are the things that, Greg is in engineering for a platform. Obviously, you're a solution developer, right? So what are the things that you see in your horizon that you may be looking at to build into the platform, or that you see as opportunities in these areas around that big data management issue?
Yeah, great question. No, what we've done is we went back a step and said, data federation. I know that back in the 80s and 90s that pattern kind of failed a little bit for performance. We took a different approach with data federation to not only provide, federated views of data, but secure federated views, so that I can do row column level security across sources, right? I can apply the same policy regardless of source. We also did some introspection into the data that we have access to, so we can identify, a column contains PII, right? This contains an individual's name, and based on that, I can then apply the appropriate governance controls associated with that. There's a monitoring aspect of that, and this is really kind of securing more of the end user access, right? So you don't have a user that comes up, writes a query, and sticks a thumb drive in their machine and walks out the door. You want to monitor, what they have access to, what queries they've written, ensure that in the data that you've got it appropriately masked, and then there are certain agencies that actually require you to do another level of data masking so that you can't infer identifiable information in the data, and that's got some additional computational complexities associated with that. So, for instance, I can't look at somebody's transactions and historic data in such a way that I can infer that this person is actually Greg, right? I need to mask his information in such a way that I couldn't deduce that. And I think that's, very similar thing occurred with the Netflix prize a few years back, when they kind of were able to take a look and say, well, we know which movies were rented from certain locations. I can actually infer who these people were based on their movie rental habits. So there's some really interesting things that you can do, but that's probably at the far extreme. Today, it's still just protect what assets you have, make sure somebody doesn't walk out the door or email themselves the keys to the kingdom, and do sufficient monitoring on the system to know who has access to what and what they're doing with it.
So I'm sensing a real lag time in the skills evolution behind some of the technical ability to just consume and store data.
Yeah, and there's the lineage aspect. I think Greg made a great point about being able to track the data as it flows through your system. You really want to have the ability to say, this piece of information was created at point A in the system. It got ingested or created here. Here's every single thing that it was used for or done with. And that's becoming more and more a business problem as much as it is an IT problem. I need to have, when I define something as, sales order credit, what exactly does that mean, and what's the quality of the data, what transformations are being applied to it? When you get into analytic models, you get bleed over, into things that you're restricted from using when you're building an analytic model for, say, credit scoring. You still got to be able to trace the lineage of that to make sure certain attributes aren't used when building those credit scoring models.
That's a good point. Actually, talking about lineage, once you actually distribute people's ability to create and publish metrics about your business, you want to be able to use leverage experts in your organization, as opposed to just having a central team that manages all your metrics for you. But as you distribute the responsibility for metrics, how do you actually validate that what you came up with is correct? That you filtered out, for example, bots out of the page views that came into your site. What we've done at LinkedIn is we've created something called the Unified Metrics Pipeline as sort of a gold master place for where metrics, trusted metrics, are stored. And we defined metric owners to have expertise around specific metrics. And then in the lineage models that Michael referred to, then you'd know which metrics you could trust, then that you could derive additional metrics from as well. So there's a whole set of complexities around managing the certification and trust of your metrics.
Yeah, Greg, that's very interesting because it brings me back, in my mind at least, to the process owners in a manufacturing process, right? So, you would establish a certain owner for that process, and they would drive that forward. So there's some lessons that people in business can take that they may already be familiar with, and then bring it to other areas in terms of managing big data processes. So let me follow up. Here's another question from our followers on Twitter. Again, if you do have a question, please send it out, post it with the hashtag RSBDA. And here's a question. This one's very interesting because we're starting to see some firms like Oracle begin to embed software on silicon. So the question here is, can we use hardware like security chips for Hadoop security rather than just software methods? And just me on this, as an aside, I think we started off years and years ago with integrated hardware and software, and we split them apart. And now we're probably in an era where we're starting to knit them back together, and that'll happen in many different areas of computing. I'm off my soapbox now, guys.
Oh, okay. I think oftentimes hardware and software can be interchangeable. Once you need that degree of flexibility, you're going to keep it in software. But once you get a pattern down, then you can always encode that into hardware. I remember in the old days when when you wanted to do an SSL transaction and negotiate that SSL handshake with your website, everything on your Apache web server was in software, and then SSL concentrators came along, and so you were able to then embed that into hardware. Same thing with encryption and decryption, different protocols, and we're embedded into hardware as well. So yeah, actually, you can use hardware for any type of, to participate in any kind of type of security protocol, even for Hadoop, rather than just software methods. As long as you kind of establish what the common patterns are, and I don't know that those common patterns have been established just yet.
Mike, you have a point of view on that?
Yeah, at SAS we're seeing a big push to get more of the math closer to the chips. I mean, we do very specific things by chipset on the advanced analytics front. So I can imagine, sure, at some point there'll be all sorts of little machine devices with methods and components built into the chips for sure.
Yeah, I think it's a use case issue. I think general purpose computing, the separation and the pace of change in software is so much faster than hardware, as you gentlemen know. So I think when we're talking about Internet of Things, pushing some of the analysis out to the edge, maybe helping with, as the question had around security, which brings me back to this issue of veracity, right? So is the data that you're getting good data, right? We're running pell-mell to manage and process data. Is it any good? What do we do about those issues, particularly when we have data coming in more and more frequently from outside our control domain? How do people adapt and build skill sets for addressing veracity as an issue?
Okay, I can take that. So one of the things, you're right on, Stuart. One of the things is that oftentimes you can compare one piece of data to another piece of data. So for example, at LinkedIn, we have warm signups and cold signups. A warm signup, I invited you to sign up. Cold signup, you just came to linkedin.com and you just created an account. Well, warm signups plus cold signups should equal total signups. And so you can put in facilities in place, almost like integration testing, if you will, that continually run over your data and then compare records to each other. You can do that in some cases here to be able to validate the integrity of what's coming in. That's one method. And that's one method that we are now embarking on pretty significantly. Sort of a validation test system for data, like you would have for software source code.
Yeah, I mean, I could see, particularly where we have machine data coming in, if there's something in between that's impacting readings or a malfunction on the device side, you could get, very quickly get vast streams of data that are off. Maybe they're off by a little bit, or maybe they're off by some significance. Probably easier to find when they're way off kilter. And then part of me gets really paranoid and wonders about people spoofing devices and sending bad data towards things that are really important.
Well, that's a good point. I think what you bring up is the whole general area of anomaly detection. How do you notice when you have anomalies in data that this data deviates significantly from data like it in the past? And then how do you quickly drill down to understand what the root cause is? Is it an error in the data or something really bad happening or a trend happening in the business?
So, Mike, I think one of the things that I would love to do would be to ask you, as a solution provider, how do you guys help people build the skills? Obviously, you're working with your partners, your professional services partners. What's the gap that you see between kind of the state of the art and where the enterprise buyers are today? Are they 6 months behind? Are they 18 months behind?
Yeah, I think it depends. I mean, some of the enterprise buyers are, they're bleeding edge in some cases, even in some of the banks, which historically I would have thought have been, behind by 18 months or more. I think for us, and Greg brought up a great point about anomaly detection, there's the quality metrics on a column-by-column basis or on a file-by-file basis, but very rarely do folks actually take a look at anomalies within the data. And so, for instance, you could have a situation where you have, somebody who's got, zero income but filed a $80,000 capital gain in a data set. Chances are that's an actual anomaly, but if you look at the individual columns and do your standard data, you're probably not going to catch something like that. Or, integrity issues which can't possibly exist in the real world but exist in the data. Those are types of things where the opportunity for applying machine learning methods and newer methods really come out. And that's where some of the things we're doing in software and the data science team here at SAS is to apply machine learning methods to do just that. Anomaly discovery relative to data integration, data quality work, in addition to anomaly detection for things like fraud detection and the like.
So I'm just going to take this opportunity again to remind those folks following us on the broadcast that if they have questions, they can post it to the hashtag RSBDA, and we'll collect those. That's B as in boy, D as in data, big data. And so let's get those questions coming in. I want to follow this thread a little bit further around this gap between the people who are working, and so we have industry by industry. We have a lot of different use adoption rates and things like this, right? And then we see broad-based advertising for data scientists and mathematicians and things like this. Obviously, we're in an early stage of a big wave of transformation. What are each of your thoughts? Both as somebody who's building tools for the data scientists and somebody who's probably hiring data scientists for work inside LinkedIn. About how we begin to close those skill gaps. Is it more intelligence in the software? You see IBM going down that route with Watson, or is it more skills, more broad-based education, and easier to use tools that help people to attack problems kind of more piecemeal?
I'll take that one. At SAS, we're doing a lot. We have headed down the path, like Watson, to have smarter machines, right? We've got some methods for doing anomaly detection and some other machine learning methods. The other thing, though, is we're also embracing the educational market. We recently launched SAS U, which provides University Edition of SAS. We've had over 100,000 downloads of that free to researchers and academics, which is a big win for SAS. We've been kind of ignoring some of the academic community in the past, so now we're back in there. So, besides just the standard training, what we see is a lot of folks coming from non-statistical disciplines, the computer scientist, the guy who's really good programming. Now he wants to learn about machine learning, data mining, and the like. Where does he go? SAS, we have a number of both publicly available courses as well as for paid courses on just that, to educate folks on, hey, how do you do data mining and machine learning, especially as it relates to big data environments. And you'll see the rise of a lot of that in the data science community, where folks have taken what they consider really sophisticated methods, and they actually see what people in like the fraud arena have done. They're pretty basic, and so you see that transition from basic to more advanced methods now starting to take place.
Greg, do you have a point of view on filling the skills gap internally at LinkedIn? It must be a challenge.
It is a challenge because LinkedIn looks, in order to be considered a data mining engineer or data scientist or machine learning engineer at LinkedIn, fortunately or unfortunately, LinkedIn is looking for people who are quite skilled and expert in the domain. Less inclined to take somebody who says, hey, I took a machine learning class on Coursera, so hire me to do machine learning for LinkedIn. It's just, to be honest with you, it's not going to happen. So the question is how do you teach people to get more advanced techniques in doing logistic regressions at scale, in doing clustering algorithms, and being able to derive that insight into data. One of the things that really impresses us at LinkedIn when we're interviewing folks is that they've done data analysis outside of the normal coursework that one would expect in a university. They've either had a very interesting internship where they've demonstrated some skills, or frankly, they've taken some public data that's out there on the internet, and they've derived some very interesting insights from that to show us what they can do. The online education is available to really learn some advanced techniques in machine learning. And frankly, there is public data available out there that one can navigate through to demonstrate their skills as well.
I think that, Greg, that's a great point. Goes back to the hiring. We take a look at SAS. We have very close ties to NC State and their Masters of Advanced Analytics program, and there's 2 or 3 other universities that we have very close ties with there. But they all come back and do projects, and they're fairly sophisticated where they're running multiple techniques not just data mining. It could be a combination of combining forecasting and machine learning and search techniques for actual businesses. I think that's important. When we are looking for somebody at the data science team, the team that I manage, we typically give them some data problems, and so they have to go off and chew on the data and then bring in and do a presentation. And I'm seeing that style of interview become more and more popular out there in the data science community, because you're right, you don't want to get somebody who just took a Coursera class. It could be the best thing, but unless you've actually got something to vet their skills, anybody can say words like neural nets and support vector machines and sound like they're on top of their game. Very few folks. You really want the guy that can actually apply them.
Absolutely, yeah. We have a 6-part interview around data mining at LinkedIn. It kind of goes into all these details in quite some depth. But,
so this sounds like some real best practices here for businesses, and also for the CS grads and the engineers who have some background in this area, who may be on this listening to this hangout. Certainly, sounds like there's an incrementalism in the development and hiring. So we talked earlier about how firms can close their gaps, by not jumping right in, building competencies in their data processes, appointing process owners. Also, in the hiring of that, it probably sounds like if I'm in a business that doesn't directly understand how to manage what the opportunity is and how to manage this, maybe bringing in some people, doing some internships, talking to my peers about how they're getting value from this is another approach for me to rapidly and very quickly iterate on some of these options before I actually put them into play across my whole business. Is that something you guys would recommend from a best practice point of view?
Absolutely, absolutely.
Yeah,
I think having that relationship with local universities and running internships is important so that you can identify quality candidates and bring them in and sort of foster them along, as well as vet the ones that aren't, right? If they haven't potentially done an internship of substance, you may not want them doing really valuable analytic modeling.
Also, in order to build skills, in addition to university classes like we've been talking about, what I've found is that a lot of conference proceedings are freely available after the conference is concluded. And I just got back. I was at the VLDB conference, a very large database conference in China, about a month and a half ago. And there you've got really good research from Chris Reeves' team at Stanford, Joe Hellerstein's team at UC Berkeley, University of Wisconsin-Madison. There's a lot of good schools that are doing some really good work in this area, and a lot of what you can learn is available, frankly, freely available online.
Yeah, I'll just add to that, Greg. The other thing, as I have my stream of consciousness, the other thing that I found has been really helpful as more of a practitioner, somebody who wants to get into the data science realm, is participating in Kaggle competitions. They're usually well-structured competitions, and you can really take some time, and there's enough examples of what people have done in the past that you should be able to kind of work your way through a problem and see what worked and didn't work, and kind of test your mettle, relative to a lot of other competitors. But that seems to be a great place to sort of vet your skills and some methods.
Yeah.
So I want to bring up, we have about 10 minutes left till we get to the top of the hour. Again, if folks have any questions, they should please tweet them out to RSBDA with the hashtag RSBDA so we can pick those up. I do want to talk about some of the emerging areas of technology, and one of the questions that came in certainly probably talks a little bit about that in terms of pre-processing on the edge, the use of IoT devices on the edge. instead of just in the data center? So is there a way to take the intelligence and put it out on the edge, or does that change the data? Any action that you take on an object changes it, right? That's the Heisenberg principle.
Yeah, you know, one of the big initiatives at SAS is moving the analytics closer to the data. And in some regards, that's pushing our processing to run in Hadoop. And in other places, that's actually pushing our processing to run on stream as data is created on stream. I think that's, you know, probably a big initiative for folks, especially in the transactional environment, you know, putting smarts in on devices and the like. I think you'll see more and more of that out there in the industry.
I agree with you. Actually, and in the you know, in the area of the web, a lot of folks are using Kafka as a publish, or as a open source publish subscribe mechanism, so that you can have multiple publishers and multiple consumers of data then share information across that wire. And as that information is shared, then the question is how do you transform that data in flight? So instead of actually sticking it into a repository like Hadoop and then generating insights, how can you actually filter, aggregate data as it's, you know, being transported from point A to point B? That's something that we're working on at LinkedIn with something called SAMSA, which we have recently open sourced, very similar to Storm. And that's a form of basically processing data in flight instead of just waiting for it to be ingested into into either an MPP repository or into Hadoop for analysis.
Yeah, we have a similar initiative here with our event stream processing engine, which uses both kind of a SQL metaphor for aggregating and structuring data on the fly as it streams through the system, providing procedural windows. The key is, you know, when you need to make a response or a decisioning, you know, back to a calling system and low latency environments, you know, that requires you to kind of think about how you're ingesting the data and you know, the thread pools and the like of, you know, I'm going to make a decision in 20 milliseconds, like in the case of a credit card swipe, is vastly different than, you know, I want to take huge volumes of log data, stream it in, and aggregate it as it's coming in, and then land it. You can do micro batches and the like to get extreme amounts of throughput. But that's often at odds if you needed to do a very low latency response. But I see that as a big coming initiative as well. And I'm actually kind of interested to see what SAMSA has to offer.
Well, it sounds like we have a sidebar open source conversation that's going to happen. Obviously, we have an explosion of consumer devices. We have everything that's going to be measured. There's going to be an option to measure it. Some things that go back to this quote, right? Some things that should be measured and analyzed can't be measured, and some things that can be measured shouldn't be measured, right? I'm paraphrasing here. As we go forward, right? This is a little bit more of an open conversation to kind of wrap up our conversation about big data. Let's bring it back to we're coming out of the age of transactional data. That's B2B. We're getting a huge flood of consumer to consumer, person to person data, and then a lot of data just about me, about yourself, in different contexts: health, sports, driving, interrelationships, location data. You know, what are some of the opportunities that come out of this? And so maybe you could talk, each of you could talk about one or two opportunities and a key threat that's on the horizon that we need to all be conscious of and to start thinking about how to solve. It's a big question.
That is a big question. So how would you summarize your question?
So the key question is, right, so data is not just about businesses anymore. It's becoming big data is ubiquitous, and it's incredibly personal data, right? A lot of it is incredibly personal, even if it's just dates and times that I went through toll booths, right?
Yeah.
How do we manage that? What are the issues and opportunities for businesses, and then what are some of the cons, the issues that we have to wrestle with?
Okay, so that is a great question. I'd say, we started off, the first question that came in was around security, and privacy is a close cousin of security. We had, so Google, Facebook, LinkedIn had all had pretty detailed audits by the Irish Data Privacy Commission. And a lot of the view there was what is the information that's being collected, how is it anonymized, what's the retention period, and how do you make sure that you get rid of the data that you don't need to provide services. If I don't need the data to provide a suitable service to a member, then why would I need to keep that data in a non-anonymized manner, right? What are we planning to do with it? And so we were very careful about setting up data cleansing intervals and anonymizing that data that we don't need to directly provide value back to a member. Like, for example, one of the services that we offer is who viewed your profile. So if Michael views Stuart's profile and Stuart wants to see who all viewed his profile, how long do we really need to keep the fact that Michael viewed Stuart's profile? These are the questions that we answered, not just for the Irish Data Privacy Commission, but for ourselves at LinkedIn as well. And the point is that if you don't actually, once the service is actually delivered or rendered to the member, you either anonymize or you destroy the data.
I think that's great. I think what Greg just described is a great opportunity for a startup. Somebody on the infrastructure side to actually go out, see what's being used, see how it's being used, and then purge the stuff that's not being used. At SAS, I see opportunity with the volumes of data, and it really just comes down to the creative uses of taking advantage of what's out there, whether it's individualized analytics of saying, my route to work is this, and if I went this other way, I'd shave 10 minutes off my route, to some of these health monitoring apps that basically say, hey, you need to stand up and walk around for 10 minutes every day, and you'd lose a pound or two. I think that application of advanced analytics on all this data provides a real opportunity for both individuals and businesses. Probably I see the biggest threat would be getting government regulation involved in how you have to handle data. And eventually something around that is going to come. It's just, how invasive is it, and then, what the ultimate costs are going to be. But I see all these data sources and, these instruments basically pitching out data as huge opportunity for folks to do advanced analytics.
Great. So I'm just going to go. We have like 1 minute to wrap up here very quickly. Greg and Mike, any last thoughts? And then we'll do a wrap up.
No, I guess my only last thought is that next week at the conference, I'll be talking about how we're trying some of the challenges that we have at LinkedIn in addressing navigating through big data in more of a self-service manner, and then how we provide facilities at all levels of the stack, from basic computation to workflow management, data ingestion, validation, and reporting and querying. And so I'll be talking about then what we're doing specifically, if that's of interest.
Yep, and here at SAS, our big initiative right now is getting the SAS University edition out to the masses, educating the next generation of data scientists. I see a big opportunity in sort of the social responsibility aspects of data mining, and just the application of machine learning in new and creative ways. I think that's really the untapped opportunity that all of us have.
Great. Well, Greg Arnold and Michael Ames, both of you, thank you very much for joining us today on the IEEE CS Live Big Data Hangout. Thank you for your time and your comments. And I want to thank everybody who's been following us on the live broadcast and sending questions in through Twitter. Many of us will be reconvening at the IEEE Rockstars and Big Data event in San Jose on October 21st. Anyway, thank you very much, and have a good evening.